Hello, we have come to the final lesson on exponents. I hope you have enjoyed this series and are ready to tackle any exponential challenge. We are ready for examples that combine all your knowledge of how powers work. So, by the end of this lesson, you should be able to simplify exponents by using all the laws of exponents, using prime factors, using negative exponents, and using common factors. Let's look at this example. Simplify 2 to the power 3n times 6 to the power 1 minus n, all divided by 4 to the power n plus 2 times 3 to the power of minus n. You must learn to think about the problem first before just writing down answers. Ask yourself, what do I have here? The numerator has factors and the denominator has factors, and need bases that are the same. So in this case here, 2 is a prime number. So 2 can be written as 2 to the power of 3n multiplied by, our 6 is not a prime number. What are the prime factors of 6? It will be 2 times 3. That means that we can be written as 2 times 3 all to the power of 1 minus n divided by 4 to the power of n plus 2. Now 4 is not a prime number. So 4 can be written as 2 to the power of 2 all to the power of n plus 2 multiplied by 3 to the power of minus n. Simplify the top. That will give us 2 to the power of 3n. Use our distributive law. That means 1 minus n multiplied to 2 and 1 minus n to 3. That will give us 2 to the power of 1 minus n multiplied by 3 to the power of 1 minus n divided by 2 to the power of 2 times n and 2 times 2, which gives us 2n plus 4 times 3 to the power of minus n. Now that we've raised to the power, what will be the next step to do is to add the exponents. That will be equals to 2 to the power of 3n minus n gives us 2n plus 1 multiplied by 3 to the power of 1 minus n divided by 2 to the power of 2n plus 4 times 3 to the power of minus n. The bases are the same there and the bases are the same here, and we are dividing. We apply again our second law. It says if the bases are the same, we simply subtract the exponents. That will give us 2 to the power of 2n plus 1. You take away 2n and 4 multiplied by 3 to the power 1 minus n. Take away minus n. That will give us the 2n and minus 2n will give us 0. 1 take away minus 4 will give us 2 to the power of minus 3 multiplied by 3 to the power of 1 minus n. Now this is very important, guys. Remember, if you have a negative and a negative together, that will give us a positive. So if we have a negative n plus a positive n, that will give us 0. So we're left with 3 to the power of 1. Our solution here will be 3 over 2 to the power of 3. Before we move on to something different, let me show you a technique which we'll use in the examples to come. What is 1 over 2 to the power of minus 1 equals to? This can be written as 1 to the power minus 1 over 2 to the power minus 1. Now remember, we can write negative exponents as positive exponents. In this case, this will be the same as 2 to a positive 1 over 1 to a positive 1, which will be equal to 2 over 1 all to the power of positive 1. Can you see a fraction raised to a negative exponent is equal to the inverse of the fraction raised to the positive exponent? Look again. 2 over 3 all to the power of minus 2 will be equals to the inverse of our fraction here, which will be 3 over 2 all to the power of positive 2. So now you can see that a fraction with a negative exponent will be equal to the inverse of that fraction to a positive exponent. By the way, sometimes it is useful to also have negative exponents in a calculation. So let's have a look at this. We're given a fraction with a positive exponent. We can rewrite it with a negative exponent. But the important thing now is that it gives us the inverse of that fraction. Your denominator becomes your numerator, and your numerator becomes your denominator. How will this knowledge help us to simplify this one? 3 over 2 all to the power of m plus n multiplied by 2 over 3 all to the power of m minus n. Well, let's start by writing each number with an easy exponent. This can be written as 3 over 2 all to the power of m multiplied by 3 over 2 all to the power of n times 2 over 3 to the power of m multiplied by 2 over 3 all to the power of minus n. Let's keep these fractions the same, 3 over 2 and 3 over 2. Let's invert this 2 here. That will be the same as 3 over 2 to the power of m times 3 over 2 to the power of n times 3 over 2. Now that we've inverted this, that means your exponent changes. It was positive, it becomes negative. Multiplied by 3 over 2. We inverted this one as well. Our exponent was negative. That means now it becomes a positive exponent. Right, as you can see, the bases inside the brackets are all the same. So what do we need to do? Simply add the exponents. Now this will be the same as 3 over 2 all to the power of m. Add the other m to be minus m plus n and plus n. That will give us m, take away m, gives us 0, plus n, it will be n, plus n, it will be 2n. So our answer will be 3 over 2 all to the power of 2n. Can you see how it helps to make the bases the same so that we can apply the rules of exponents? One last challenge for you before we send you off with a task. Simplify this one. 3 to the power n minus 3 to the power of n plus 1. What we've used so far doesn't help us too much, does it? But look, we have two terms here. We could try and find a common factor between the two of them. We'll have 3 to the power of n, and this one can be written as 3 to the power of n times 3 to the power of 1. We have a common factor of 3 to the power of n. Take out 3 to the power of n. We'll be left with 1 here, and there we'll be left with 3. So we have 1 minus 3. That will be equals to 3 to the power of n. 1 minus 3 will give us minus 2. So our answer will be 3 to the power of n times minus 2. That brings us to the end of this lesson. What we have learned is that to simplify exponential expressions where we deal with factors, you have to write the numbers as prime factors, raise a power to a power, multiply or divide, write negative exponents as positive exponents, and lastly, use common factors. Here's a task for this lesson. Simplify. Number 1, 12 to the power n plus 1 multiplied by 9 to the power 2n minus 1, all divided by 36 to the power n times 8 to the power 1 minus n. Number 2, 9 to the power n plus 3 to the power 2n plus 1, all divided by 3 to the power of n. That's all for today. Salani gahle.